Seventh grade, it's week 17, and we're talking about mountain building and earthquakes. By the end of this lesson, I'd like you to be able to explain the mechanisms involved in the building of mountains. So, how do plate motions create mountains? Plate tectonics processes create some of the world's most beautiful places. The North Cascade Mountains in Washington State are a continental volcanic arc. The mountains currently host some glaciers. There are many features left by the more abundant Ice Age glaciers. Changes in altitude make the range a habitable place for many living organisms. Many processes create mountains. Most mountains form along plate boundaries. A few mountains may form in the middle of a plate. For example, hotspot volcanoes. Most of the world's largest mountains form as plates collide at convergent plate boundaries. Continental crust is too buoyant to get pushed down into the mantle. So when the plates smash together, the crust crumbles upward. This creates mountains. Folding and faulting in these collision zones makes the crust thicker. The world's highest mountain range, the Himalayas, is growing as India collides with Eurasia. About 80 million years ago, India was separated from Eurasia by an ocean. As the plates collided, pieces of the old seafloor were forced over the Asian continent. This old seafloor is now found high in the Himalayas. Volcanic mountain ranges form when oceanic crust subducts into the mantle at convergent plate boundaries. The Andes Mountains are a chain of coastal volcanic mountains. They are forming as the Nazca Plate subducts beneath the South American Plate. Cotopaxi is in the Andes Mountains of Ecuador. The 19,300-foot tall mountain is the highest active volcano in the world. Mid-ocean ridges form at divergent plate boundaries. As the ocean floor separates, an enormous line of volcanoes is created. Continents can also rift apart, a process called continental rifting. When continental crust is pulled apart, it breaks into blocks. These blocks of crust are separated by normal faults. This is known as block faulting. The blocks slide up or down. The result is alternating mountain ranges and valleys. This topography is known as basin and range. The area near Death Valley, California, is the center of a classic basic range province. The photograph in the background here was taken of a basin with a range in the distance near Death Valley, California. We see the same block faulting in Nevada and Utah as well. Our own Salt Lake Valley is part of a normal fault system that has sunk down between what is now two sets of mountains. In summary, converging or diverging plates cause mountains to grow. Subduction of oceanic crust beneath a continental or oceanic plate creates a chain of volcanoes. Tension forces bring about block faulting. This creates a basin and range, valleys, and mountains. So, if you are comfortable explaining the mechanisms involved in the building of mountains, please move on to the questions. If not, go back to the video, view it one more time, and take some notes. You're welcome to use the notes on the questions. Have an awesome day. Talk to you later.